everybody. In this video, we're going to talk about multiplication and division and some of the thinking strategies you can use to help your students understand these concepts. So in multiplication, the two parts of the problem that are multiplied together are called the factors. And when you multiply the two factors together, you get the result, which is called a product. In division, the dividend divided by the divisor equals the quotient, and sometimes you'll also end up with a remainder. So when you're teaching multiplication, there's a couple different models that you can use. The first one is to think about it as repeated addition. So let's say, for example, you were trying to model the multiplication problem 3 times 4. If you were thinking about it with the repeated addition model, with a set model, you would think about it as a group of 3 that's being duplicated 4 times. And so you would look at that and you'd say, well, how many items do I have altogether? If you count those up, we can see that 3 times 4 equals 12. If you're showing it with a measurement model, you're going to count by 3s 4 times. So you would go 1 to 3, then 3 to 6, because there's 3 units between each of these. And you would repeatedly add 3 4 times. Whoops, went a little bit too far there. And that also gives the result that 3 times 4 equals 12. And so that's the repeated addition model for multiplication. Another model that you can use is the rectangular array model. So if we look at this rectangle, the number of squares along one side, or the length of the rectangle, is 7, and the width of the rectangle is 4. And so this rectangular array models the problem 7 times 4, which equals 28 because there's 28 squares total. And this is kind of similar or related to the idea of repeated addition. It's just organizing the items a little bit more clearly. Because basically what we have here is we have 7 plus 7 plus 7 plus 7. They're just arranged in a rectangle, so they're really easy to see. And so this is the rectangular array model. And another model that you can also use is the Cartesian product model. And this is actually the formal definition for what multiplication is, because the Cartesian product says that if you have two sets, A and B, that are finite, it should actually say that they're finite, then the number of items in A times the number of items in B is going to equal the number of items in A cross B. So for example, if A has these elements and B has these elements, then the set A cross B is going to have the ordered pair where you have A1, A2, B1, B2, C1, and C2. And if we count the number of items in set A, there's 3 items. The number of items in set B is 2, and the number of items in A cross B is 6 because we have 1, 2, 3, 4, 5, 6 ordered pairs in the Cartesian product. And so this model is one that you can use to teach multiplication, but you probably wouldn't want to teach it in like the set notation way because that might be kind of confusing for your students. But you can teach it with a tree diagram. So a tree diagram is something that's used a lot in probability and combinatorics. And basically what it does is it visualizes all of the choices that you have. So for example, if you were wanting to buy a car and you had the choice to either buy a sedan or a hatchback, and then you had 5 color options to choose from, well, you could make a tree diagram where you list out all of your choices. So the first layer of your choice tree would have 2 branches because you have 2 choices between a sedan or a hatchback. And then branching off of each of those choices, you would have 5 branches because you have 5 choices for a color. And basically what this does is it lists all of the possible choices that you could make for the style and color of your car. So this branch of the choice tree represents having a sedan that's black. This branch represents having a sedan that's red. This one's a sedan that's green. This one is a sedan that's dark blue. This one is a sedan that's light blue. And actually, maybe I should use a D for dark blue on that since I already used B for black. But basically, those would be the lists of all of your choices that would be possible for a sedan. And then you would have the same for the hatchback, where you would have a hatchback that's black, or a hatchback that's red, or a hatchback that's green, or a hatchback that's dark blue, or a hatchback that's light blue. And the total number of options is 10, and this is basically just a visual way of finding the Cartesian product, because this list of choices right here is basically the same information as if you had a set that had the ordered pairs of a sedan that's black, or a sedan that's red, and so forth. And so a choice tree diagram can be helpful for visualizing the Cartesian product. And you probably don't want to start with this when you're first teaching kids multiplication. It would be better to do it as repeated addition or a rectangular array. But this can be a helpful additional way of thinking about it once students kind of have a basic idea of how multiplication works. So when we're doing whole number multiplication, we have several different properties, just like we did with addition. And the first property is the closure property. So just like we did with addition, the closure property of multiplication basically says when you take two whole numbers and multiply them together, the product or the result is going to be a whole number. So multiplication is closed over the whole numbers. And then we also have a bunch of other properties. We have the commutative property, associative, identity, zero, and the distributive property. So I'm going to go through each one of these properties and show you guys visually why this property works. So for the identity property and the zero property, we can think about this and we can say, okay, for any whole number, a times 1 equals a, and a times 0 equals 0. So let's say that I have a equal the number 5. Well, to show that 5 times 1 equals 5, I could use the set model of repeated addition, and I could say, okay, well, if I have 5 things and I add that to one group of 5 things, that's just going to equal 5. And if I have a times 0 equals 0, well, if I have 0 groups of 5 things, well, that's nothing. And so 5 times 0 would equal 0. And so that's the way that you can visualize the identity and zero property. And then for the commutative property, we could look at it with a rectangular array. So if a and b are whole numbers, the commutative property says you can do a times b, and that's going to give you the same result as b times a. And if you look at it with a rectangular array, this makes sense because 3 times 4 is 3 that's been copied 4 times and arranged in a rectangle. And 4 times 3 is a 4 that has been copied 3 times and arranged in a rectangle. And you can see that those rectangles are the same rectangle, they've just been rotated slightly. And so this is a visual way that you can show students that the order of the multiplication does not matter. Then the next property is the associative property, and we'll use a 3-dimensional version of the rectangular array to show this. So the associative property basically says if you have 3 numbers that are multiplied, it doesn't matter which 2 you multiply first. So you can multiply the first 2 or the last 2 together, and the results will still be the same. And so we can do this as an example, and we can say, okay, well, if I do 2 times 4, that means that I have a rectangle that's 2 units by 4 units, which would give me a rectangle with 8 squares in it. And then if I multiply that by 3, I'm basically making 3 copies of that. And if I counted up the number of cubes in that shape, that would be the same number of cubes as if I did 4 times 3, where I have a rectangle that's 4 units by 3 units, and then I made 2 copies of it. And that would form the same rectangular shaped block. And so that's a way that you can visualize the associative property for multiplication. And then the last property is the distributive property. So the distributive property says that if you have a number multiplied by 2 other numbers that are being added together in parentheses, then you can multiply this number by both of the numbers inside of the parentheses separately and then add them together. So the distributive property is technically called the distributive property of multiplication over addition. And there's also the distributive property of multiplication over subtraction as well. And let's look at why this is true. So let's say that A was the number 2, and B was the number 3, and C was the number 1. And we're trying to show that this is equal to 2 times 3 plus 2 times 1. Well, if we visualize what this looks like, 3 plus 1 is basically a group where 3 things have been combined together with 1 thing. And then when you multiply that by 2, you're basically doubling that group. So you have 3 things and 1 thing in another group. And the distributive property basically says that this is equal to having 2 groups of 3 plus 2 groups of 1. And so if you look at this, you can see that these two amounts are equal to each other. It's just splitting up the groups and how they're grouped together. So you can either double them when the 3 and 1 are combined together, or you can double them when they're separate, but it's still doubling it, and so the amounts end up being the same. And so that's how you can visualize the distributive property. And the reason why this matters is because just like with addition, it can make memorizing your multiplication facts much easier. So just like with addition, the commutative property allows us to basically cut off like half of our facts that we need to memorize, because if I know what 5 times 2 is, then I also know what 2 times 5 is going to be. And so the commutative property makes it so that I only have to memorize half of my multiplication table, and that will give me the memorization for the other half. The zero property also makes it really easy to memorize your zeros, because 0 times any number will equal 0. So all of these facts in the multiplication table are easy to memorize. And the identity property also makes it easy to memorize all of your ones, because any number times 1 is just going to equal that number. Then the next strategy that you can teach your students to help them memorize their multiplication facts is the idea of doubles and halves. And so if you take any number and double it, that's the same thing as multiplying by 2. So if you do 3 times 2, that equals 6. 5 times 2 equals 10. 6 times 2 equals 12. And by doubling your numbers, it basically allows you to memorize all of these multiplication facts. And then if you understand the idea of halving, that can help you memorize all of your 5s. Because let's say, for example, you have 6 times 5. Well, you can think about this as 6 times 10 and then split that in half, because 10 divided by 2 equals 5. And so, and when you explain this to your students, you can say, if I want to make 5 copies of 6, well, I could make 10 copies and then just take half of it. And so because 6 times 10 is 60, if you divide that by 2, that gives you 30, which is 6 times 5. And you can also do this even if you have like an odd number, like if you have 9 times 5, well, 9 times 10 is 90, and if you split that in half, well, half of 90 equals 45. And so understanding the idea of halves can help your students understand all of the multiplication facts that are multiplied by 5. And so that can help with those ones. And then associativity can help you memorize all of these yellow ones. For example, if you are doing 6 times 4, it might be easier to think about this as 6 times 2 times 2, because doubles are easier than multiplying by 4. So you could say 6 times 2 is 12, and then if you double that, then that would equal 24. Or like if you were doing 7 times 8, you could think about this one as 7 times 2 times 2 times 2. Because you could go 7 times 2 is 14. 14 is easy to double because that's 28. And if you double 28, that would equal 56. And so by giving your students these thinking strategies where you think about multiplying by 4 as multiplying by 2 twice, or multiplying by 8 is like multiplying by 2 3 times. Or you can also do this if you're multiplying by 6. Like for example, if you're doing, I don't know, like 8 times 6. Well, you could think about it as 6 times 2 3 times, or you could think about this as 8 times 3 times 2. And if they have memorized that 8 times 3 is 24, then they could just double that, which gives them the number 48. So a lot of these thinking strategies will overlap each other, but these properties of multiplication are basically where the thinking strategies come from. So another trick that I really like teaching my students when I teach multiplication is the nines trick. So the nines finger trick basically works on the way that our base works. So since our base is base 10, the number 9, which is one less than the number 10, has this interesting pattern to it. So the way that the nines trick works is you hold up your fingers, and from left to right, you count over whatever you're multiplying by 9. So like, for example, if you're doing 9 times 6, you would count over 1, 2, 3, 4, 5, 6, and you fold this finger down. So you fold that finger down, and whatever is on the left is the tens column, and whatever is on the right is the ones column. So 9 times 6 equals 50, because that's to the left of your folded down finger, and then a 4 in the ones column because that's what's to the right. So 9 times 6 equals 54. And then you can do this for any number times 9. So you could do like 9 times 8. If you count over 1, 2, 3, 4, 5, 6, 7, 8, and you fold this finger down, the number of fingers on the left is 7, and the number of fingers on the right is 2. And so that's one trick that's really helpful for helping kids learn the nines. And so that basically knocks out this entire row for memorization. And then the last few gray problems that can't be figured out with associativity can be figured out with the distributive property. So for example, if you have 3 times 3, one way that you can think about this is to think about this as 3 times 2 plus 3 times 1. Because it's easy to double 3, and it's also easy to make one copy of 3. And so if you're trying to make 3 copies, you can kind of split it up into little groups and make the copies separately. So what this would tell us is that 2 copies of 3 is 6, and if you add that to 1 copy of 3, that gives you a total of 3 copies of 3, which is 9. And you could also do this with like a 7 times 3, because you could just replace the 7 here. And you could say, well, 2 copies of 7 is 14, 1 copy of 7 is 7, and if you add those together, you get 21. So ultimately, when it comes down to it, there's lots of different thinking strategies that you can use, and the same multiplication fact may have multiple different strategies you could use to memorize it. But it's important to give your students lots of different thinking strategies so that they can choose the ones that make the most sense to them, and so that they have a conceptual understanding of how to figure out what multiplication means. And just like with addition, you can use these thinking strategies even when you're multiplying numbers that are bigger than 10. So like if you had 2 times 34, one way you could think about this is that you're going to make 2 copies of 30, and then you're also going to make 2 copies of 4, and then you'll add those together. And this can make it a lot easier to be able to do mental math, because you can say, well, 2 copies of 30 is just 60, 2 copies of 4 is 8, and if you add those together, that's going to give you the number 68. And if you have the problem 5 times 37 times 2, you could use the commutative property to switch the order, and you could say I have 5 times 2 times 37, and then you could use the associative property to think about this as 5 times 2 times 37, and this would be a lot easier to solve because 5 times 2 is 10, and 10 times 37 is 370. And so that would be an example of a situation where you could use the associative and commutative properties to make that problem easier. And if you had a problem like 7 times 25, you might want to think about this as 4 copies of 25 plus 3 copies of 25, because 4 copies of 25 is just 100, And so that's an easier calculation to do than making 7 copies of 25. And then you can say, well, 3 copies of 25 is 75. And when you add those together, that gives you 175. And so that would be an application of the distributive property, because you're basically, rather than making 7 copies of 25, you're going to make 4 copies and 3 copies of 25. So now let's talk about division. So one way that you can think about division is that you have an amount and you're going to split it up into groups. And the way that you split it up into groups can be thought of in 2 different ways. The first way is called sharing division. So an example of this would be if a class of 20 children is divided up into 4 teams and you want to figure out how many children are on each team. So if you were trying to model this, you would say, okay, well, let's say that we have the 20 children and we want to split them up into 4 different teams. So I might have circles that represent those. Then I could say, okay, well, this child's going to go on this team, this child's going to go on this one's going to go here, this one's going to go here, and then I'll kind of color code these. This one's going to go in here, this one's going to go in here, this one goes over here, this one goes here, and then this child goes in here, this child goes here, this child goes here, and this child goes here, and then this child goes in this one, this child goes here, this child goes here, this child goes here. And then lastly, this child goes over here, this one goes here, this one goes here, and this one goes here. And obviously this would be easier if you were working with kids, because you could have physical objects that represent the 20 children and then you could have them split them up into 4 teams. But basically you count up the number of children that end up in each team. So we've got this black one, the blue one, the red one, the yellow one, and the green one. And so each team has 5 children in that team. And this is one way that you can model the problem 20 divided by 4 equals 5. And you can also think about it in a different way, which is called measurement division. So in measurement division, you're still splitting the group of children up into teams. However, instead of splitting them up into 4 teams, you're splitting them up into teams of 4 people each. So you still end up with the same answer. We're still going to get 20 divided by 4 equals 5. But the way that we're modeling it is different. Because rather than taking the 20 children and splitting them up into 4 teams, we're going to split them up into teams of 4. And we're looking at how many teams are there. And again, the answer is still 5, but it's a different way of thinking about it. So sharing division usually tends to be easier to model with sets, so like groups of objects, versus measurement division can often be easier to show on number lines. And another way that you can also introduce division is connected to the idea of fact families. So just like in addition and subtraction, where you have 4 different math facts that are all related to each other, in multiplication and division, you also have that dynamic. So one way that you can think about the problem 18 divided by 3 is you can help students realize that this is basically saying 3 times what equals 18. And if they've got their multiplication facts memorized, that can be an easy way to figure out the answer to a division problem. So we basically have 3 different ways that you can model division. You could think about 18 divided by 3 as 3 times a missing number equaling 18. You can think about 18 as being split up into 3 groups and you're trying to figure out how much is in each group. Or you can think about 18 as being split up into groups of 3 and you're trying to figure out how many groups there are. And those are kind of the 3 different ways you can think about division. And this idea of using the missing factor model can help us understand how to divide when a 0 is involved. So if I take each of these division problems and rewrite them as a missing factor problem, 0 divided by 3 would be rewritten as 3 times what equals 0. 8 divided by 0 would be rewritten as 0 times what equals 8. And 0 divided by 0 would be written as 0 times what equals 0. And if I look through these missing factor problems, it's easy to see which ones are able to be defined and which ones are not. Because if I look at the first one, 3 times 0 does equal 0. And that's the only number I could put here that makes the multiplication equal 0. And so that means 0 divided by 3 equals 0. However, if I look at the second one, 0 times what equals 8? Well, there's nothing that you could multiply by 0 to make it equal 8, because 0 times anything always equals 0. And so this is an undefined answer because there is no number that when you multiply it by 0, you get the number 8. However, if you do 0 times what equals 0, this one has an infinite number of answers because 0 times 12 equals 0, but you could also have 0 times 278 or 0 times 1. And there's actually an infinite number of numbers you could multiply by 0 to get 0. And so in this case, because there's an infinite number of solutions, we call this an indeterminate answer because it's not possible to determine which one out of all of the infinite options we should define the answer as. And so this is one way that you can help students understand why it's okay to do 0 divided by a number, but you can't do a number divided by 0. And the missing factor model can help illustrate that. So to wrap up our discussion about division, let's talk about remainders really quick. So sometimes when you do division, it will work out and you'll get a whole number as your answer. However, sometimes a whole number may not be able to be divided evenly into another whole number. So for example, if you had 14 people and you were dividing them into groups of 6, well, you would have enough people to put in one group, and then you'd also have enough people to put in 2 groups because 2 groups of 6 is 12. However, you wouldn't have enough to make a third group. And so the answer to this would be 2 remainder 2 because we had enough people to make 2 groups. So that's where this 2 comes from. But once we put 2 people or 6 people in each of our 2 groups, that used up 12 of our people. And you have 2 people that are left over that are not in a group. And so that's the idea of a remainder. And so whenever you have a remainder, the dividend, which in this case would be 14, is always going to equal the divisor, which in this case is 6, times the quotient, which in this case is 2, plus the remainder, which in this case is 2. And if you check this, 6 times 2 equals 12, and if you add 2, that does equal 14. And so this is one of the properties of remainders. And the remainder should always be smaller than the thing that you're dividing by. So if this remainder was like an 8, then that would tell us that we didn't divide it correctly because if you had 8 people, you would still be able to create another group of 6. And when you're teaching remainders to students, the way that you teach it depends on which model you're using. So if you're using the sharing model of division, which is where you say, okay, I have 14 people and I'm going to split them into 6 groups. So here's my 1, 2, 3, 4, 5, 6 groups. And I say, okay, this person's going in this group, this person's going in this group, this person's going in this one's going here, this one's going here, this one's going here. And then I say, okay, then this person's going in this group, this person's going here, 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 and here, like this. And obviously this is easier if you actually have physical objects and you're like arranging them in groups. But I'm just trying to show it visually on like a whiteboard format. But if you do this, then you can see that each group has 2 items in it. And so you'd have 2. And then the remainder is described as the leftovers of like your group of people. And so when you're using the sharing model for division and you're splitting your amount up into a certain number of groups, the remainder is going to be the leftover items that didn't get assigned into a group. If you're using a measurement model, which is where you have groups of a certain size, then in this case, it's helpful to use repeated subtraction because basically you say like, okay, I have 11 items and I'm trying to make groups of 3. So I'm going to subtract 3 because that would be one group of 3. then subtract another group of 3, then subtract another group of 3. And this tells me that 11 divided by 3 is going to have 3 whole groups of 3. And then the remaining piece is going to be the number 2 because I don't have enough to make another group of 3. And so my remainder basically is where I end up at when I can't make any more groups of that size. And so that's what the remainder would look like when you're using a measurement model. So to summarize, we have 4 different models for multiplication. So we have the repeated addition set model, where you repeatedly add the same amount of items to a set. And then you have the repeated addition measurement model, where you repeatedly kind of like skip count along a number line. You have the rectangular arrays, where you arrange a rectangle that has whatever numbers you're multiplying as the side lengths of the rectangle. And then you also have the Cartesian product, which you can model with trees. And I wouldn't recommend doing the Cartesian product early on, but later, like in 5th grade or so, it can be a helpful topic to approach then. And then division has 3 different models. So we have sharing division, which is where you're splitting an amount up into a specific number of groups, and you're looking for the number in each group. And then we also have measurement division, where you're splitting up the items into a specific size of group, and you're looking for the number of things in each group. And then we also have the missing factor model, where you rewrite the division as multiplication to help you figure out the result for the division. And then we also talked about 2 different models for remainders. So if you're doing sharing division, you can think about it as the leftovers, because sharing division is where you split it up into a certain number of groups. And the leftovers are the ones that you can't divide up into the groups because there's not enough of them. And then if you're doing measurement division, you can do repeated subtraction until you've subtracted it so much that your remainder is smaller than the number that you're dividing by. So that's it for our lesson on multiplication and division. If you guys have any questions, let me know.